Hello, welcome to this video. So in this video, I'm going to give you 4 examples from the Pearson's question pool to show you how to calculate the mean and the standard deviation for random variable. So let's look at the first example. A citrus farmer has observed the following distributions for the number of oranges per tree. How many oranges does he expect on average? This means what is the mean of the orange number? Okay. Here, this is the data. Give you the orange. A tree produce 15 orange. The probability for a tree to produce 15 orange is 0.1, and produce 20 orange is 0.5. Produce 25 is 0.3 and 30 is 0.1. So if you want to do this by hand, you're going to do 15 times 0.1 plus 20 times 0.5 plus 25 times 0.3 and plus 30 times 0.1. But we can do this quickly in StatCrunch. Normally, when you click on this, and you can directly open this data in StatCrunch, but sometimes it won't give you the option. So you can do copy clipboard or open in Excel and then copy the result and put them in StatCrunch. But I found those 2 ways are not reliable. The second one is slow, and the first one sometimes they won't copy for you. See, this one gave me nothing. So what I'll do is you can quickly type this data in StatCrunch. So the orange is the numbers. Let's type the numbers first. Make sure you put the numbers in the first column. And the numbers is 15, 20, 25, and 30. 15, 20, 25, and 30. And the corresponding probability is 0.1, 0.5, 0.3. 0.1, 0.5, 0.3, and 0.1. Okay. So, just to remind yourself, let's say this is our probability. Okay. So you type the values in the first column, and then the corresponding probability in the second column. What you need to do is just go to Stats, Calculators, and Custom. Okay, Stat, Calculate, Custom. So the first one says the values. What is your values? That's our orange numbers, right? So you're going to do the first column. That's our orange. The title is O, so you change the O. Select the O. The weights. The weights corresponding to the probability. So we're going to do the weights is the second column, which is probability, and then you just compute. You see that this is the output, and this mean 22, that's your average, and std.dev, this means standard deviation. And for this case, you can just ignore the second output. What relevant is here, the mean and standard deviation. That's what we're interested in this video. So we'll say, okay, that my mean is 22. Okay. So here it says type of integer or decimal. What this means is don't round your data. If you get something like 22.22, just keep that. So in this case, we just happen to get an integer. So you just keep that. And let's look at the next. Okay, so the next example is still about the number of orange and the corresponding probability. Here it tells you what the average is and ask you what is the standard deviation for this distribution. So the reason why they gave you the average is assume that you're going to do this by hand. If you do this by hand, you're going to take the difference between each value and the average and then square the difference and then times the probability. And next step, you're going to plus the second number minus the mean, square that, and time probability. Keep doing all of those. But as I showed you before, we can do this in StatCrunch. So let's not waste our time to explore those two options. Let's just type in our data. So orange numbers, you can open a new empty data table, new data table. Okay, so let's put my orange number in my probability. Okay, so my orange number is 30, 40, 50, 30, 40, 50, and 60. And my probability 0.2, 0.4, 0.3, 2, 0.4, 0.3, and 0.1. Okay, and once you get the data list out, the numbers in the first column, probability in second column, you do the same thing. Go to stats, calculators, and custom. Choose the number of your oranges, that's the values, and then the probability as the weights, and compute. And we get the mean is 43, standard deviation is 9. If you check that, you can see here it says the 43 average per tree on average, right? The 43 oranges per tree on average. So that's the mean. Did you see that? You get a mean by yourself. If they don't give you, you can still know that by using StatCrunch. In this question, you just need to find the standard deviation, which is the second number right here, standard deviation. So let's look at two more. Okay, this question says a commuter must pass through 5 traffic lights on her way to work and will have to stop at each one that is red. She estimates the probability model for the number of red lights she hits, as shown below. The probability that she hits 0 red lights is 0.061, and this is the number of red lights she will hit, and this is the probability for each number. And compute the mean or expected value of the random variable. So the mu is just the mean. Sometimes we'll see expect value, sometimes we'll see average, sometimes it's mean, but you know that they're the same thing, just the average. So as before, we can open a new data table. Let's do this. StatCrunch, you can open a new data table. Let's do this side by side. Type in our values. Make this window smaller. Okay. So let's type our numbers. X is our numbers 0, 1, 2, 3, 4, 5. And our probability P is 0.06, 0.24, 0.34, 0.14, 0.13, 0.09. And now you're looking for the mean. You just go stats, calculator, custom. Choose the value, your X, and choose the probability, your P, and compute. And this is the mean. And it says round to 1 decimal. So that will be 2.3. That's the mean. And if we look at the next example, it says now compute the standard deviation of this random variable X. So this sigma here is the standard deviation. So looks like we have the same number from 0 to 5, so keep that. First probability, second probability is 0.25, and 3, 0.13, and 0.13, 0.19. Yeah, we can keep this table, and you do the same thing, stats, calculator, and custom. Values, by this time you must be very good at this now. Compute. and you can see this is your standard deviation. If round to one decimal, that will be 1.4. Okay, so that's all about this video. I hope it's helpful. Thank you for watching.